Now we are going to discuss about Coulomb's law. Coulomb's law stated that the force between two very small objects separated in a vacuum or free space by a distance which is larger compared to their size is proportional to the charge on each and inversely proportional to the square of the distance between them. Now, the force between the charges can be expressed as F is directly proportional to the Q1 into Q2 divided by R squared. Here, Q1 and Q2 are the charges. It may be either positive charges or negative charges, and its unit is coulomb. R is the distance between the charges in meter. F is the force in Newton. Now, we want to omit this proportionality. So, the effect of the medium is introduced in this force equation as constant of proportionalities denoted as K. Here F is equal to K into Q1 into Q2 divided by R squared. Here the proportionality constant K is defined as K equal to 1 divided by 4 pi epsilon. Here this epsilon equal to epsilon naught into epsilon R, where epsilon equal to permittivity of the medium in farad per meter and epsilon naught equal to permittivity of the free space or vacuum, epsilon R equal to permittivity of the medium with respect to free space. For free space or vacuum, the relative permittivity epsilon R equal to 1. The permittivity of the free space epsilon naught is 1 divided by 36 pi into 10 to the power of minus 9, which is equal to 8.854 into 10 to the power of minus 12 farad per meter. This value is a constant value you have to remember. Now we look at the problem. Find the force of interaction two charges separated 10 cm apart in a vacuum. The charges are 4 into 10 to the power of minus 8 coulomb and 6 into 10 to the power of minus 5 coulomb respectively. So this is the given problem. Now we want to write the given data. Here two charges are given. Let us take the first charge is Q1, so which is equal to 4 into 10 to the power of minus 8 coulomb, and second charge is Q2, which is equal to 6 into 10 to the power of minus 5 coulombs. The distance between the two charges is 10 cm. Convert to a meter, which is equal to 0.1 meter. Here the epsilon R is 1. How do I identify it is equal to 1? Because in the given problem is a vacuum as a medium. Therefore epsilon R equal to 1. So what is the force expression formula? F is equal to Q1 into Q2 divided by 4 pi epsilon naught into epsilon R into R squared. Now you know the value of Q1, Q2. Then epsilon naught, this is the constant value which is equal to 8.854 into 10 to the power of minus 12. This is epsilon R is given in the problem, which is equal to 1. Next, this is the R is the distance, which is equal to 0.1 meter. Just substitute all the values and getting this result, 2.157 Newton. Consider the two charges. The charges are Q1 and Q2. So this charges is located R1 distance from the origin. This charges is located R2 distance from the origin. Now the distance between the charge Q1 and Q2 is represented as R12. We want to find the force extracted on the charge Q2 due to charge Q1. What is the formula? We know the force expressions. F is equal to Q1 into Q2 divided by 4 pi epsilon naught into epsilon R into R squared. Now the force extracted on the charge Q2 is denoted as F2. Yes, which is equal to Q1 into Q2 divided by 4 pi epsilon naught into epsilon R. Here epsilon R is considered as 1. Now this R squared is the distance. So the distance between the charge Q1 and Q2 we are represented as the R12. So it is a vector form. If you are applying the magnitude of this, you are going to get the distance R12. So that value you are going to substitute. Now here force, it is a vector quantity. It has directions. So here A12 is represented as the vector, that is unit vector along the directions R12. Now this A12 equal to R12 vector divided by modulus of R12. Here the R12 is equal to R2 vector minus R1 vector. Then this modulus of R12 which is equal to modulus of R2 minus R1. That means how you are finding the unit vector in the first unit, likewise here is also going to proceed. Now instead of finding the charge on Q2, now we are going to find the force on Q1 due to Q2. Such a case, the F is represented by F1. So F1 which is equal to Q1 Q2 divided by 4 pi epsilon naught epsilon r, here epsilon r equal to 1 into R21 the whole squared. Here is the vector is also A21. So while comparing this result, F1 result and F2 result, the only change is only the sign. The magnitude is remain same, but the direction will change. Now the A12 is R21 vector divided by modulus of R21, which is equal to R1 vector minus R2 vector divided by modulus of R1 vector minus R2 vector. Look the problem. A charge Q1 equal to minus 20 microcoulomb is located at a point minus 6, 4, 6, and a charge Q2 equal to 50 microcoulomb is located at R of 5, 8, minus 2 in a free space. Find the force on Q2 by Q1 in vector form. The distance are given in meter. Now here you want to find out the force extracted on the charge Q2. So F2 equal to Q1 into Q2 divided by 4 pi epsilon naught into R12 the whole squared into A12 vector. Just look this. Here this is the unit vector. This is the distance. So this Q1 and Q2 are the charges. First you want to find out this R12 vector first. So what is the R12 vector? Here we have given the 2 points. What is the first point? The first point is a P. The next point is the R. The point belongs to this one is x1, y1, z1, and point belongs to this, it may be the second point. So this is x2, y2, z2. Now how to find the distance vector? Now you want to find the distance vector. The distance vector is x2 minus x1 into ax plus y2 minus y1 into ay plus z2 minus z1 into az. Okay, this is a formula, you are already familiar about that. Now you have to substitute it. You are going to get the distance vector equal to 11ax plus 4ay minus 8az. Now you want to find out the magnitude of this. So just applying the square of this, you are going to get this value. So 11 squared plus 4 squared plus of minus 8 squared, and apply the root, you are going to get the distance equal to 14.1774. Now what is the A12? A12 equal to R12 vector divided by modulus of R12 vector. So you know the R12 vector, just now you got it. Now you know the value of magnitude of R12. So this also known, just substitute it. Now what is the A12 vector? Simplify this using calculator and verify this results. Got it? What is the formula? F2 equal to Q1 Q2 divided by 4 pi epsilon naught R12 into A12. Just now you know all the values now. Just substitute all the values here. Yes, this is the Q1 value, this is the Q2 value. So 4 pi is a constant. This is the epsilon naught value, this also constants. This is my distance value r. Now this is a A12 value. You just substitute the value here and simplify it and verify this answer. Okay. If you want magnitude of this force, just apply the square root of this. You are going to get this answer. So the final force is 14.634 millinewton. Till now we discussed about the Coulomb's law and we deal with only two charges. Suppose if you have more than two charges, then how to solve this problem? Such a case, we introduce a concept is called as principle of superposition. Here we have n number of charges. The charges may be marked as Q1, Q2, Q3 up to Qn, and the distance between the charges and the origin point is R1, R2, R3 up to Rn. Now you want to write the force expressions. The force of ith charge is given by the vector sum of all the individual force. It can be written as F is equal to summation of j is equal to 1 tends to n qi into qj divided by 4 pi epsilon naught into epsilon r equal to 1 here into r squared ij into aj vector. Here j is not equal to I, where qj is any of the charges other than qi and rij is the distance between jth and ith charges. Now you just look this problem. Three positive charges of 0.2 microcoulomb is located at the vertices of an equilateral triangle of 10 cm side. Determine the magnitude and direction of the force on one charges due to the other two charges. So this is the given problem. Now the given problem is equilateral triangular, that means all the sides are equal. So the given triangular side is 10 cm, so all the side is 10 cm. Now the charges are 0.2 microcoulomb. It is a positive charges. So you have to mark the charge Q1, Q2, Q3. So how can you mark the charge Q1 and Q2? It is your wish. You can start from anywhere. I am choosing this is a charge Q1, this is a charge Q2, this is a charge Q3. So you want to find out the magnitude and the direction of the force on the one charges due to the other charges. Now you have to think which vertices you have to select. So this also your choice. Okay, you can choose any vertices. So I am choosing this top of this triangular. You can also choose either here or here, but the final result is same for all the cases. Okay, so I am choosing here. The force acting on these charges due to the other two charges. So coming to this directions, so the force acting on this point is due to the charge Q3 and Q1. Coming to this directions, in the force acting on this charge is due to the charge Q2 and Q1. Yes. Now I am taking this point. Now at this point, due to the charge Q2, the force is F21, and due to the charge Q3, the force is F31. Now we record this force F. The net force F. Now we record the force F. So this force F, okay, the net force F is a combination of x direction contribution and y direction contributions. Therefore F is equal to square root of Fx squared plus Fy squared. We want to find out the Fx and Fy. Here there is no force is acting on the horizontal movement because the force is acting on the vertical direction only. Therefore, the Fx is equal to 0. We want to find out the Fy. Fy is, we have to find, it is a contribution due to other charges. Just look here. This charge is contributed this one. This charge is contributed to this one. Now you want to move this to here, this to this directions, and this force to this directions. Now if I am moving this force to vertically like this, I want to move certain angle. That angle is theta here. Now it is a equilateral triangular. So this side angle is 60 degree, this angle is 60 degree, this angle is 60 degree. So even at this position is 60 degree. So the entire angle is 60 degree. We are making the half of it. Therefore the theta equal to 30 degree here. Here is also 30 degree. Now the F equal to F21 into cos 30 degree, F31 into cos 30 degree. So this is the expressions. Now you want to find out the F21 and F31. F21 equal to, you know the basic formula, Q1 into Q2 divided by 4 pi epsilon naught into epsilon r into r square. So here the epsilon r equal to 1, F21 equal to Q1 into Q2 divided by 4 pi epsilon naught into r squared. Just substitute all the value. You know the Q1 and Q2 value, 0.25 into 10 to the power of minus 6, 0.25 into 10 to the power of minus 6 divided by 4 pi. Epsilon naught value is 8.854 into 10 to the power of minus 12. Epsilon r value is 1. Then into distance is 0.1 squared, which is equal to 0.056 Newton. Similarly, you want to find out the F31. F31, the formula is Q1 into Q3 divided by 4 pi epsilon naught into epsilon r into r squared. Just substitute all the values and verify this answer. Now you know the F21 and F31. Just substitute it these equations and verify this answer. One more thing you have to remember in your mind. Here is your calculator should be in degree mode. Now once you find out this Fx and Fy value, you have to find out the net force. F is equal to square root of Fx squared plus Fy squared. So whereas this value is 0, then Fy squared is 0.097 the whole square, which is equal to Fy, which is equal to 0.097 Newton. Clear? This is a homework problem. You have to try it with your own and find these final solutions. You just verify this result. Thank you.